Okay, so we're still talking about the testing portion, right? So we're in the design phase. We're going to use desk checking to walk through the program, and that's where we kind of work through the program by hand. You guys, if you're going to put in a mathematical equation like the quadratic function, probably wouldn't hurt to sit down and work one out. It's going to have a huge impact on the way that you input that equation into a program, okay? In the coding phase, the software usually will alert you to errors in syntax. You type something in wrong, it's going to give you some kind of a message that you've made an error, usually a little red dot or an exclamation point or something along those lines. But one thing it's not going to do is it's not going to let you know about any errors in the logic of the program. An error in logic might be putting in the wrong formula, or an error in logic might be rounding off a number to so much that it is no longer sufficiently significant to meet the needs of the client, or turning a number into an integer. Because remember, if you turn that number into an integer, if you get a floating point number in, and then you turn that number into an integer, and then you start running calculations on it, the errors will compound, and you're going to end up with a real mess when it comes to output. But the computer will be very happy to run it, right? It'll be totally happy to run it. So that is known as a logic error because the computer's happy with whatever you told it to do. But in errors in syntax, the computer will not even let you get to square one or first base or any way that you look at it, okay? So once you get past the syntax issues and you have everything coded and hopefully you've got the logic working right, then you can finally test your program. And the key to testing, good testing, is to run as many tests as you can with various kinds of data. For example, if you're going to test the quadratic function, quadratic function is going to have an a variable, a b variable, and a c variable. All right. If you haven't coded the quadratic function correctly and you make a equal to 0, the program will crash. If you make a, b, and c equal to 1, the program is going to crash. Okay, so you want to test it with different kinds of data to make sure that it's going to give you the correct answer, because in truth you can actually solve a quadratic equation with any body of data if you write the program correctly. Okay, so we have additional steps in the cycle. Okay, we want to create an outline of the program so that it's apparent what the major tasks are. That really helps out. And off of each major task, you might want to put down some subtasks to be accomplished. This major task business and this subtask business is actually really important, because ultimately what you're probably going to end up doing is taking each major task in a program and turning it into a module. Okay, and the subtask might be methods within each module. We want to describe in detail how each of these tasks is to be carried out. So sometimes you might, if you're going to put this program together for a company, if it's going to be a medical database program, or it's going to be an appointment program for a hospital or something like that, probably wouldn't hurt to put together a user's guide and to create help files. Probably wouldn't hurt to sit down and train employees who are going to be using that program, and also your own employees that might be providing telephone or web-based customer support. So as you can see, this programming thing, this business of writing programs, can ultimately turn into quite a pretty big project, right? It's not just writing the code. It's not just coming up with the application. How are you going to market that application? How are you going to distribute that application? Okay? So we need to know, and we need to realize that programming development is a process, and it is cyclical in nature. It means that you go through and you give it your best shot that you can. You run the program. 90% of the time, if the program has any level of sophistication whatsoever, it's not going to do what we want it to do. Many times it's going to flat crash. Okay? Other times we're going to realize that there are certain features that were unanticipated. The program maybe launches into the wonderful world of what I call artificial intelligence, where the program just runs amok and kind of does whatever it wants to do, right? So the design process may uncover flaws in the analysis, but we can code the thing, we can run it, and the process of running it is going to definitely uncover any kind of flaws whatsoever, especially if we're faithful to use a lot of different testing data. Okay, so we go through, we test the program, we find the flaws, we correct the flaws, we test the program, we find the flaws, we correct the flaws, and we keep running through this cycle until we're finally really, really happy with the program. And then guess what we do? We do not give it to the client. Nope, nope, nope. What we do is we hand it to a body of people who will go ahead and test the program for us as well. All right? This is called beta testing. See, we did the alpha test. They're going to do the beta test. They will test the program for us, and then they'll report back anything that was kind of weird with the user interface or any strange results that they got back in terms of output or anything along those lines. And then what we're going to do is we're going to distribute that out to the public. The public then will run the program, and of course it will contact you with complaints about the program, and once again we're back into the cycle, right? We find out that there's a problem with the program from a customer. We uncover the flaw, we recode that section of the program, we send it back out into distribution as an update. Okay? So that is the general process of programming design. I think that's kind of all I really want to talk about at this point. Your book covers some really, really good examples that you need to read. Okay, I'm leaving it to you guys to read this as opposed to using a video, or if you're coming to my class, doing a lecture. All right. So I guess with that, I'll say happy coding.